Solving absolute value equations. Absolute value equations are equations or linear equations which have absolute value operation in them. So, equations that contain absolute value expressions or operations. Before we go over the absolute value equations and solving them, we're going to learn the properties of absolute value expressions. We're going to go over the 4 important properties of absolute value expression. So, absolute value expression is always positive, or at least it can be 0. And the second one, if it's negative, it turns into positive. If it's product, you can separate them, like absolute value A, B can be separated. And if it's quotient A over B, you can also separate it as absolute value A over absolute value B. So now we're going to talk about the equations here. So the absolute value equations look like this: ax plus b equal to c. Now to solve them, we separate them into equal to c, or then we say equal to negative c. And then we separately solve them and we get separate equations. Okay, so basically we're going to isolate the x separately on both the equations. Okay, which is normal procedure, isolating the x and doing the inverse operations, right? Let's do a couple of examples here. So x minus 4 absolute value is equal to 6. So we're going to separate them, right? We're going to have 2 equations, one with the plus 6 and one with the negative 6. Now the plus 6, we just put 6, right? We don't have to put plus 6. And then to isolate, we have to inverse operation. So we'll have to do plus 4. So to get x by itself. And the other one also will be plus 4. And that will give you x equal to 10 on the first one, and then x equal to negative 2. All right, let's do another one here. So you have 3x plus 9 minus 10 equal to negative 4. Now we need to isolate the absolute value part first by itself. So we're going to add 10. So there's nothing but the absolute value part on one side. Now that will make it isolated. 3x plus 9 equal to 6, right? 10 minus 4. And then we separate them. So we do 3x plus 9 equal to 6. And then you have 3x plus 9 equal to negative 6. And then we separate, we solve them. Okay, separately isolating the variable. It's highly advisable that you check back the answers, because sometimes these answers don't work. So for absolute value, I highly recommend you should always go and check it, like solve, put the equation back and it works, if it works or not. So now we're going to be learning solving equations with two absolute value expressions. So we do the same thing pretty much. We separate them out, one with the plus on the right hand side and then one with the, that's the first one, and then you have the other one is ax plus b equal to negative of that cx plus d. Okay, let's see an example here. So 3x minus 4 equal to x. We separate with one with the plus x or just x, and the other one is one with the negative x. And then the whole objective is to isolate the x, the variable on one side. What about isolating? All right. So as I said before, we have to identify if the solutions that you get are extraneous or do they work. Okay. So we have to understand what is the meaning of extraneous. Extraneous solutions are solutions that you get as the process of equations. You get them, but they do not work. So if you ever have to plug them in the equation, they do not make the original equation true. So they make the equation not true, which is basically they do not work on the equation. Okay? So basically the equation rejects it. Okay? All right, the next one I'm showing you here is how to do one more example here about extraneous. So you see absolute value equation. You are going to separate the two equations, one with the no sign, which pretty much means plus sign, and then one with the negative sign. And then you separately solve them, right? Now this one is pretty clear. You get 5 equal to 11, which is absurd, right? How can 5 equal to 11? So that must be extraneous. So basically this one equation does not even work. It's like a defective equation, right? And the other side, when you solve it, do your magic of solving, and that will give you all the steps you need, and then that will give you 2x equal to negative 16, and then you get negative 8. All right. Just let me go over one more thing here. Like, I want to show you like how like you can get the answer and then it doesn't work. I want to show you. Like this one was more like defective kind. Like it didn't, like it made like a statement that was false, but I want to get a solution and show you how it doesn't work. So you have 2x plus 12 equal to 4x absolute value. So you separate them. Right? You're separating. And then you're isolating the x. Now this gives you x equal to positive 6, right? And on the other one, the negative one, the one you have a negative sign on the right hand side. Right? You get x equal to negative 2. Now you need to check. I want to show you how to check. So your original equation from the question, you write that down. And then you plug in both the values, like the 6, x equal to 6. And then you also plug in so this one looks like it's working, right? 24 equal to 24. So that is true, right? 24 equal to 24. So that works. Okay. Now we're going to try the other one. The other value, negative 2. We're going to plug that in. Yeah, I didn't have more space. Like somehow it wasn't letting me write there. So negative 4 plus. All right. So I think on the last one I made a mistake. There should be negative 4 plus 12. It should come out to be 8. And then 8 is not equal to negative 8. So I messed up on the last one here. I'm going to fix that, but just to let you know, on the last step, when you have 2 times negative 2 plus, so this one, that's 12, right? And then that should make it positive 8, right? And positive 8 is not equal to negative 8, right? So that doesn't work. But this one worked, right? So this is a good solution, and that's a negative 2 is a bad solution. All right. Okay, sounds great.